Now let us try to do one example here. Suppose there is a particle of mass m which is at rest. There is a particle of mass m which is at rest. Another particle of mass m is moving with a velocity v naught. Another particle of mass small m is moving with a velocity v naught towards the stationary block of mass m. When it goes and collides, let us assume that the collision is elastic. Let us assume that the collision is elastic. Then velocity of center of mass is equal to m1 u1 plus m2 u2 by m1 plus m2, that is equal to m1 is m, u1 is v naught, mv naught plus m2 is m, its velocity is 0 by m plus m. It is equal to m plus m, that is equal to mv naught by m plus m. So velocity of center of mass is equal to mv naught by m plus m. What is the velocity of the first particle in the CM frame? Velocity of the first particle in the CM frame, velocity of the first particle in the center of mass frame. Let us call it velocity of the first particle, velocity of the first particle in the center of mass frame is v1 equal to its velocity v naught minus velocity of center of mass. In any frame, velocity of the particle is equal to velocity of the particle in the earth reference frame or lab frame minus velocity in that frame. So here also velocity of the particle 1 in the CM frame, velocity of the particle in the CM frame, should have clarity here, this v1 is velocity in the CM frame, is equal to its velocity in the earth reference frame or lab frame minus velocity of center of mass. So v1 CM frame is equal to v naught minus vcm is mv naught by m plus m. This will be equal to mv naught plus mv minus mv means mv naught by m plus m. This is the velocity of the first particle in the center of mass reference frame. What do you expect the velocity to be in the center of reference frame, in the center of mass reference frame after the collision? Already I told you that the speeds will remain same, only directions will get opposite. In elastic collision, definitely that is the result. So here we are given that the collision is also elastic, therefore the velocity of the particle after collision in the center of mass reference frame v1 dash is equal to minus mv naught by m plus m. In the center of mass reference frame, velocity of the first particle after collision. Before collision, this is the velocity of the first particle in the CM frame. After collision, in the CM frame, what will happen? Speed will not change. This magnitude will remain same, only direction gets negated. That means v1 dash is equal to minus of this only in the CM frame. Now for the second particle, initially it is at rest. So what is the velocity of the second particle in the center of mass reference frame? v2 in the center of mass reference frame, CM frame, is equal to its initial velocity 0 minus velocity of center of mass. Velocity of the second particle is initially 0 minus velocity of center of mass, that is equal to, what is the velocity of center of mass? mv naught by m plus m. So 0 minus, that is equal to minus mv naught by m plus m. So velocity of the second particle in the CM frame before collision is equal to minus mv naught by m plus m. After collision, velocity of this second particle in the CM frame is equal to minus of minus, that is mv naught by m plus m. mv naught by m plus m will come. So, in the center of mass reference frame, for the first particle before collision is this is the velocity, for this for the first particle only after collision this is the velocity. In the center of mass frame, these two are velocities in the center of mass frame before collision, after collision for first particle. For the second particle, this is the velocity before collision in the CM frame for second particle, and this is the velocity after collision. There is not much difference, except the sign there is not much difference. So, this is the velocity of the second particle after collision in the CM frame. This is the velocity of the first particle after collision in the CM frame. Understand that clearly. This is the velocity of the second particle after collision in the CM frame. This is the velocity of the second particle after collision in the CM frame. Now, how to find their velocities in the normal frame or in the lab frame or earth frame? Again, we can do it like this. Velocity of the particle in the normal frame is equal to its velocity in the CM frame is equal to, we have the formula now already, velocity in the CM frame is equal to velocity in the lab frame minus velocity of center of mass. This is the formula. Velocity in the CM frame for any particle is equal to velocity in the lab frame. My lab frame means earth frame, normal frame. Velocity in the lab frame minus velocity of center of mass. So, velocity in the lab frame is equal to velocity in the center of mass frame plus velocity of center of mass. Velocity in the lab frame is equal to velocity in the center of mass frame plus velocity of center of mass. That means, if you take the first particle, its velocity after collision in the CM frame is this value is this. If we apply this formula, velocity of the first particle in the lab frame, velocity of the first particle in the lab frame, final velocity in the lab frame, final velocity in the lab frame is equal to velocity in the center of mass frame V1 in the center of mass frame plus velocity of center of mass. For first particle, we are trying to find final velocity in the lab frame. For first particle, we are trying to find final velocity in the lab frame, which is equal to V1 lab frame equal to V1 center of mass frame plus velocity of center of mass. This is equal to, what is the velocity in center of mass frame for first particle? This one. So, minus mv naught by m plus m plus velocity of center of mass won't change throughout the motion of the particles, because it is a constant which is equal to mv naught by m plus m. We derived it in the very beginning. Velocity of center of mass means m1 v1 plus m1 u1 plus m2 u2 by m1 plus m2, which gives you mv naught by m plus m. So, this is the velocity of center of mass which you have to substitute here, mv naught by m plus m. So, this is the velocity of the first particle after collision in the normal frame, which is equal to m minus m into v naught by m plus m. This is the final velocity of the first particle in the normal frame or with reference to earth, or commonly we can call it the final velocity of the first particle after the collision. Final velocity of the first particle after the collision is equal to m minus m into v naught by m plus m. Now, for the second particle, let us see what happens. For the second particle also, same formula is valid. V2 lab frame is equal to V2 center of mass frame plus velocity of center of mass. What is the velocity of the second particle in the center of mass frame? mv naught by m plus m. Final velocity is mv naught by m plus m plus velocity of center of mass is again mv naught by m plus m. So that would be equal to 2 mv naught by m plus m. 2 mv naught by m plus m. So velocity of the two particles in the normal frame are given by m minus m into v naught by m plus m and 2 m v naught by m plus m. These two are final velocities after the elastic collision, which we are able to derive using the center of mass frame. So that is the advantage of center of mass frame. In the center of mass frame, final velocities can be known using this method. So make sure that you understand this concept of applying center of mass frame while solving problems relating to collision. Okay, let us conclude this chapter here. When we discuss the rotational motion or some other chapter, we can again review these things because these concepts are continuously required in rotational motion also.